Okay, question number 1. So list 5 properties of the F distribution. The F distribution is a family of curves, each of which is determined by 2 types of degrees of freedom. The degrees of freedom corresponding to the variance in the denominator, denoted by dfn numerator, and the degrees of freedom corresponding to the variance in the denominator, which means the FD denominator. Okay, let's check. Next one. So determine the second of the 5 properties. The F distribution, okay, positively skewed, because F distribution is constantly in the first quadrant. I would recommend, before you start doing this assignment, I would recommend to listen the video about F distribution, okay? It's in the lecture. So positively skewed, and therefore the distribution is not symmetric. Next, determine the third of the 5 properties. So the total area under F distribution, any distribution, total area is 1. Okay, what is here? Determine the fourth distribution. All values of F are greater than or equal 0. Why it cannot be between 0 and 1? Because it's between 0 and infinity. It goes as what's the name, terminology in algebra, that run into it never touches the axis. My God, asymptote, yeah, asymptote. So that's why between 0 and 1 it cannot happen. It's 0 and positive infinity. Okay? And determine the fifth one. For all F distributions, the mean value of F is approximately, now that's a different story. Mean value is 1. Moving to next question. Okay, list the 3 conditions that must be met in order to use a 2-sample F test. That has to be, the samples must be randomly selected, independent, and each population must have normal distribution. Okay, randomly selected, independent, and each population not sample. Okay, next one, question number 3. Explain how determine the value of degree of freedom numerator and degree of freedom denominator when performing 2-sample F test. Okay, find the first determine what degree of freedom numerator and degree of freedom denominator represent. So degree of freedom numerator represent degree of freedom of the numerator. Denominator, degree of freedom of denominator represent degree of freedom in a denominator. Okay. The value of degree of freedom numerator is equal to n1 minus 1, and the denominator n2 minus 1. Question number 4. What do we have here? We need to find critical value here, alpha 0.05. Okay, let me show you how we're gonna find. Alpha is 0.05. Here it is, 0.05, and we are using horizontally degree of freedom, which is 120, the last one, and degree of denominator 120 so it's going to be 120, 120, it's going to be 1.35. Both of them are 120, 1.35. Let's type it in. 0.35. Oh, to tell. Okay, where is to tell? I missed. Here it is, to tell. Okay, then we are going to look for 0.05 divided by 2. So let me see. 0.025 per tail, right? 120, 120, 1.43. Okay, so this is question number 5. The same way, we need to find critical value to tell, right? So we need to split, and we have 0.01. It's going to be 0.005. This one, 0.005. And we have numerator 8, denominator 7. So numerator horizontally, denominator vertically. So 8 and 7, 8.68. Let's type in. We are good. Moving to question number 6. So what do we have? We need to build a test, hypothesis test. Test the claim about the differences between population variances. So population, its claim is an alternative because they are looking for difference between two variances, sigma 1 squared and sigma 2 squared, at a given level of significance, alpha, using the given sample statistics. Assume that the sample statistics are from independent samples that are randomly selected, and each population has normal distribution. Alpha is given, here is claim, sigma 1 squared is greater for sigma 2 squared. So if it's greater than, it's going to be A, because null will be less equal, right? Okay. What we have next, the critical value. So since our alpha is 0.01, let's find out if we have the right tail, right? It's not the two tails. So we need to, moving to the last question. Which of the following is not property of F distribution? I'm staring right now at this answer, and it's so obvious that F distribution is bell-shaped. That's just not true. F distribution is not a bell-shaped. Okay, I'm done with this problem. Let me check. All right, we are good. So see you in next video. Use F table to find the critical value. So let's write down what we have. N1 is 8, N2 is 7, and our alpha significance level is 0.01. Okay, alpha is 0.01. So the denominator, with the degree of freedom for denominator, it's gonna be 7, and degree of freedom for numerator, it's gonna be the opposite. It's gonna be 6, and denominator is gonna be 7. Okay, so we use the smaller sample size as a denominator, and greater sample size we use as a numerator. Keep that in mind. Okay, so we're going to look 0.01, 6 denominator, 7 numerator. 6 denominator, 0.01 here, and 7 is going to be numerator. Numerator is going to be this one at the end. Here 0.01, it's going to be 8.26. 8.26. Let's try 8.26. Where is my... I'm going to clean this. Okay. It was 26, right? Let me double check just in case. It's 6 and 7, 8.26. That's right. Okay. Let's see. Excellent. Okay. So what did I say? I want you to remember the smallest one is always gonna be in denominator. The greatest sample size goes into numerator. Okay, keep that in mind, please. And the test statistics, how much is gonna be? Test statistics is gonna be the we need to take and divide. So S1 squared is 815. Let me see. 815, and 8 to square 615. So we're gonna get 815 divided by 615. So F statistics is gonna be S1 squared divided by S2 squared. Remember the lecture? 815 by 615. And if we punch the numbers, 815 divided by 615, and we're getting 1.32. Let's type it in. 1.32. I didn't square. Gee. No, it's given squared. So one more time. 815 divided by 615. Yeah, those are squared. 1.33. I didn't round it. 1.33. Okay, silly mistake. See? Bingo. Okay, so and lastly we need to draw decision, conclusion. So what do we have? Our what is it? Critical value. We are going to use here critical value, and F test statistic critical value is 8.26. F critical 8.26, and F the statistics, it's 1.33. So since we have critical value 8.26 somewhere here, and 1.33, it's falling in healthy area, which means we failed to reject null hypothesis. And we are going to support our claim, which means it's gonna be we fail to reject null hypothesis. We have two cases, fail to reject, A or B, which means our claim is alternative, so we need to draw decision about alternative. If we fail to reject null hypothesis, then we draw decision about alternative, right? So that means we reject alternative, and there is not enough evidence to support the claim. fail to reject null hypothesis and there is not enough evidence to support the claim. Okay, well done. Number 7, what do we have here? The claim is sigma 1 squared, the variance of first population is less equal variance of second one. It's B here. I already marked down. And so we have sample statistics 452, N1 is 8, and 415, and N2 is 12. So let's check this one first. This is correct. Now we need to find critical value. Because we have here degree of freedom 11. The table I placed the link to doesn't have 11 degree of freedom. It's a 4 numerator. That's why I'm going to use calculator. So N1 it's going to be 7, N2 is going to be 11, and 0.05. So it's going to be 7 and then 11 and 0.05, right? Let me double check. 0.01. So 11 and 7. Very good. So once we click, I'll place this link also in the denominator. We get 3.01. Okay, let's write down. Let's test it. 3.01. Okay, well done. Now we need to find test statistics. Test statistics, we already know what to do. Test statistics is we're gonna do 452 divided by 415, because S1 squared divided by S2 squared, and we get 1 point, how many decimals to 1.09. 1.09. Okay, well done. So what else we have left here? Draw a correct conclusion. So what we have here, critical value 3.01, test statistics is less. That means we fail to reject null hypothesis, right? But our claim is, null hypothesis. That means there is not enough evidence to support, right? To reject, I'm sorry. There is not enough evidence to reject. And here it is. I picked automatically, but I picked the right one. It seems to me C and D it's the same, huh? There is not enough evidence. It says support. No, we need reject. Okay. So because our claim is null. All right. Moving to question number 8. So what do we have here? Test claim about difference between blah 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 blah. You can read it. I already see data are given. Sigma 1 squared equals sigma 2 squared. This is our claim. Where is our equal? It's right here. Okay, so to tell. Next we are going to find the critical value. So for total we are going to split, instead of alpha 0.1 we are going to get 0.05. Okay, degree of freedom 9 and 18. Degree of freedom 9. Degree of freedom 18. And 0.05, we split it. And we get 2.46. 2.46. 2.46. 6. All right, we did fantastic job. And do we have anything else? Now, test statistics. Okay, we know what to do with this one. So let me grab my calculator. 10.5 divided by 3.5, and I'm getting precisely 3. This time it's going to be different story. We have test statistics greater than critical value, which means we're going to reject null hypothesis, and null hypothesis our claim. That means if we reject null hypothesis, there is not enough evidence to support. Reject null hypothesis, there is enough evidence to reject. That is the answer, because null hypothesis is cooperating with the verbiage reject. Question number 9. A company A claims that the variance of the life of its appliances is less than the variance of the life of company B's appliances. A random sample of the lives of 20 of company A's appliances has variance 2.5. A random sample of lives of 21 of company B's appliances has a variance of 3.5. At alpha equals 0.05, can you support company A's claim? Okay, first of all, we know that claim is null hypothesis, always going to carry equal sign. So let's understand what is going to be our claim. So it says company A claims variance is less than variance for companies B. How much is variance of companies A? It's 2.5, right? 2.5. And for B is variance 3.5. So since 3.5 is greater than 2.5, so 3.5 is going to go to numerator, right? Because S1, it's going to be greater. Then and smaller number goes to denominator, because it's for F statistics. Okay. So since we are going to get that understand that 3.5 is greater than 2.5, then let this 3.5, it's gonna be 3.5 S1 squared, which is gonna be for company B, and 2.3, it's gonna be S2 squared, which is for company A. Right? Okay, so from here we are going to write down claim, since it says that company A claims that the variance of life of appliances is less than variance of life of companies B. Then we are going to write down S1 squared is less, right, equal sigma 2 squared. And that is going to be null hypothesis, because we know that sigma 1 squared is greater than sigma 2 squared. Sigma 1 squared was 3.5, I believe. Sigma 2 squared was 2.3, right? Okay, let's see. 2.5 and 3.5. Okay, let it be. But at least we know that it's supposed to be 3.5. It's going to be S1 because it's greater, and 2.5 is going to be S2, which is 2.5. And it's going to be greater. We always, because we divide bigger number by a smaller number, therefore that's why we chose the variance of 3.5, it's going to be S at the sigma 1 squared, and smaller variance going to be sigma 2 squared. Okay, let's check it. The next critical value I typed by accident and came out wrong, and I didn't start deleting, because I noticed I tried several times, and seems to me, and with several calculators, seems to me it doesn't match with any calculator. So the second decimal, it's gonna be wrong. So it's always by the second decimal gonna be wrong. So I will recommend I want to complete this assignment to tell me, and I'll give you this half point. So 1.6, 1.4, it's a matter of calculator or table, and I tried several ways practically and got the same error all the time. I don't know what they are using, maybe StatCrunch. I didn't use StatCrunch for this because I have to type it in everything by hand. You can try it. Type S1 squared, S2 squared, in sample size 1, sample size 2, and go for it. See how it will work, and let me know. I'm curious. But as of now, we are continuing. Critical value, you practically are not going to compare to F statistics, but just because they don't require here the exact value of F test. So all we have to do, it says what is the rejection region. For rejection region, it has to be, F has to be greater than F0, yes, then it will fall in rejection area. Since if it would be two-tail, then we would split alpha to get the critical value. Okay, so but now we need to calculate the test statistics, which we have to do S1 squared divided by S2 squared. Our S1 was how much? We decided that S1 is going to be our company B, right? Because it has greater variance, and it's going to be 3.5 divided by 2.5. And we are getting precisely 1.4. Let me write down one. Where is it? Oh, here it is, 1.4. All right, fantastic. What is next? Next we need to find out this decision, make decision. So if our test statistics 1.4 and the critical value is 2.16, then we fail to reject our null hypothesis, right? Because it's falling in the healthy area. So it's gonna be okay. Now interpret the decision in the context of the claim. Can you support company A's claim? Okay, because we fail to reject null hypothesis and claim is alternative. Remember, we had the claim is less than, so on. So claim is alternative, and since we fail to reject null, then we reject alternative, and we said no, there is not enough evidence to support the claim. Question number 10. What do we have in this case? A random similar problem. By the way, a random sample of 31 waiting times in minutes before patient saw a medical professional That's pretty good waiting time. Medical professional in a hospital's minor emergency department had variance of 1.96 minutes. After a new admission procedure was implemented, a random sample of 22 waiting times had a variance of 0.09 minutes at alpha equals 0.1. Can you support the hospital's claim that standard deviation of the waiting times has decreased? So if let's see which one is going to be our the sigma 1 squared, one is going to be, which one is going to be sigma 2 squared. So which one is greater sigma, meaning variance? First one we said variance 1.96, and the second one is variance 0.09. So we are going to choose sigma 1 is squared is greater than sigma 2. Yes. Minor emergency department variance, a new administrative procedure, implement a random sample. Can you support hospitals' claim the standard deviation of waiting time has increased? Well, it hasn't increased. Okay, well, we are going to test it. So we are looking at greater, right? So has increased, which means sigma 1 squared is greater than sigma 2 squared. Okay, well done. Next we are going to determine critical value and rejection area. So, well, obviously I expect the second decimal be incorrect, but let's see. We have how much is 31 is a waiting times. That's first sample size. Second one is 22 and 0.1. 31 and 22. So 30 and 22, which is gonna be 21 and 0.1. I believe I said right. Double check. 0.1. Okay, 22 will be 21 and 30. I think I placed everything correct. Okay, and we get how much? 1.72. Okay, let's see. 1.72. Oh, interesting. This time it took it. Next, what is the rejection area? Well, obviously rejection area is gonna be greater than, right? If it's less than, then it's not rejection but fail to reject area. All right, now test statistics. Let's figure out our greater variance is 0.0 how much is 1.98 and 0.09. Okay, 1.98 divided 0.09. We take biggest one, right? Greater one, divide by smaller one. We got the big number. Hold on. Oh, 0.09. 1.98. 96 actually. I'm sorry. Divided 0.09. I'm getting 21.7. That is too big. Let me see. Well, I'm curious. Let's put in there. Well, let's see what's happening. 21, how many decimals? 2, so it's going to be 2178. Wow, okay. I thought it's too big, but no, well, evidently it's not. Okay, so next we need to decide whether reject to fail, reject or fail. So since 2178, it's our test statistics, 1.72 is our critical value, then obviously it's falling in the rejection area. So we reject null hypothesis. And since we reject null hypothesis and our claim is what? Our claim is alternative 1. So if we reject null, then we fail to reject alternative, and we say yes, there is enough evidence to support the claim. We are good. Moving to question number 11, we have 2 more questions with once we calculate this 11.1, once we solve this 11.1. Okay, so what do we have here? The table below shows a sample waiting time in days for heart transplant for 2 age groups. At alpha equals 0.05, can you conclude that the variances of the waiting time differ between 2 ages? Okay, differ. Here we are going to have 2-tail tests, right? Because it doesn't say greater or less, it says differ. So where is our null hypothesis? Equal and then not equal. It's going to be A. Here it is. You see here I have already answers for B and C because I recorded how I calculated, but then I got in StatCrunch and found there, I saw how to figure out the critical value and the test statistics, so I'm going to go over and show you. So the bottom line is we are clicking on StatCrunch. So here is our data, raw data, and I'm clicking on Stat, Calculator, and picking F test. Since F test is going to be right tail, I'm clicking here and picking right tail. Now I have to place here my sample sizes. One was 7, 1, 4, 5. So degree of freedom, it's gonna be 4. And first I'm putting the smaller one. Second I'm putting the greater one, which is 6. And it's gonna be 0.025, right? Because it's 2-tail, I'm splitting. And let me see, I'm getting 6 point, look here, 23. And I got this way the answer, 6.23. So obviously rejection region, it's gonna be greater than. Now let's go for F statistics, F test statistics. So getting in there, stat, we are taking variance. We have 2 samples. Did I choose variance? Yes. Choose the 2 samples, and we have raw data, right? Not summary, raw data. We're choosing raw data. First one is going to be 1834. Second one is going to be 3549. And compute. And I'm getting F statistics 1.26. Let me plug in here. 1.26. Check. Excellent job. Okay, so and we need to next reach to the decision, because our the test statistics is less than our critical value, so we fail to reject, right, or do not reject null hypothesis, and our claim is alternative, then we are saying that what do we use? Evidence to conclude that the variances of the waiting times differ between two groups. There is not enough because we do not reject. Since we do not reject null hypothesis, right, then there is not enough evidence to conclude that variances are different, because if we accept null hypothesis, then we reject alternative. Okay, check. Very good. Moving to the last question. Which of the following is not property of F distribution? I'm staring right now at this answer, and it's so obvious that F distribution is bell-shaped. That's just not true. F distribution is not a bell-shaped. Okay, I'm done with this problem. Let me check. All right, we are good. So see you in next video.